Well, good morning. Top of the morning to you. This is me over at my mom's in Studio B today. And this is a tiny little notebook, and I'm just kind of writing down some thoughts today. And the other day I was thinking about weather forecasting and its associated data gathering. And years ago, when the home satellite craze was popular, when you could get HBO for free before all the crap went on, I used to be interested in geosynchronous satellite data, and I probably spent more time listening to the data on the geosynchronous satellites in the C-band, they call it. That's where HBO and Cinemax and all those things used to be. And there's still some stuff on C-band now, although probably most of it's encoded. I got interested in what they call APT satellites. These are satellites that are belong, I guess, technically to NOAA, and they're a organization that does most of your weather. And the APT satellites are automatic picture transmission satellites, or what they call polar orbit satellites. They aren't geosynchronous. Geosynchronous satellites they appear not to move because they are far enough out that the speed of the satellite's orbit matches the rotation of the Earth. They actually do move around. There's a kind of a box they have to stay in. The control centers down on the ground kind of scooch them around. It's very interesting, actually. Anyway, the NOAA satellites that gather weather picture information, what they call polar orbit satellites, and they rotate around in an orbit from north to south. And if you think of it kind of like the rings of Saturn, only tilted on a vertical axis instead of horizontal, what happens is the orbit stays the same, goes around and around and around, but the Earth rotates underneath, so it's kind of like holding a camera still and letting the scenery go by. It's actually kind of interesting, and there are plenty of programs to track those satellites and stuff. I was interested in that more than a few years ago, quite a few years ago. But at the time, I didn't have the money or the knowledge or the resources to pursue it very well, and it was sort of a little bit obscure, required quite a bit of hardware. Today, in the 21st and a half century, this looks like this ought to be a no-brainer. There's really three main areas you need to concern yourself with, and I was going to kind of pursue this as a little fun project and see how far I got. The first area is the antenna, which is actually pretty easy. Thank you. Pretty easy to do. This all happens in the 137 megahertz range. This is just a little bit above the FM band, standard broadcast FM band, and a little bit above the aeronautical band. But a few of the problems I'm going to run into are, one is the receiver. I need to find a receiver for this, and the third area I need to worry about is a decoder. Now, the decoder is probably a no-brainer with today's modern technology. There are plenty of free programs to decode things nowadays, especially data with sound cards on your PC at home. Looks like all you have to do is just find a decent program and away you go. And this is very similar to the decoding I did in the series, the weather facts, or the HF facts series that I experimented with. It's not the same format, but it's pretty similar. You receive the data and ram it into your PC sound card, and then the software kind of decodes it. The receiver might be a little tougher, but not unobtainable nowadays. Originally, I had tinkered with the notion of using a police scanner, or just a RF scanner, or a service monitor. One thing I'm going to run into the problem is that those things are kind of geared up more for voice than they are for data, and the bandwidth is a little narrow. And what the bandwidth of those is typically 15 kilohertz, and I believe the APT satellites are in the 30 kilohertz range, so I'm going to lose half the bandwidth. And so it'll probably chop into the picture. If the bandwidth is too wide, then the noise will creep into it, and you'll get kind of a noisy picture. So it's important you have the proper bandwidth. One thing that might be a possibility is there's been a recent kind of flood of what they call software-defined radios, and they've gotten pretty cheap. Matter of fact, they've gotten to the point where they're kind of like little USB dongles that hang off your PC or laptop. I might investigate that a little bit further. The antenna is really not a big deal to me. You'll need what's called a turnstile antenna, or I believe that's a helical antenna. The polarization that those satellites transmit is actually, I believe, right-hand rotation, which is kind of unusual. But there are plenty of good articles, and a little scouring of some antenna books I had should yield some good information. Now, one other potential antenna problem I might run into is, to get a good signal, I might have to invent some sort of a tracking system. Not necessarily, but it would help if I use like a Yagi or one of those type antennas. I'll need to invent a tracking system with some rotors or some servos or something. Yeah, it might be fun, and it might be something that's computer controlled, and I'll have to figure out how to determine where the satellite is as it flies by. It'll be interesting. And those satellites really don't, what I'm going to say, as the orbit goes by, they don't go, horizontal, or vertical from us. They don't go straight north to south, because the Earth is rotating in there, so they kind of go at an angle or a skew. So it'll be interesting. And those orbits kind of go around and around and around. And I need to read up a little bit on the transmission modes and some of the data and stuff. The current satellites are, they've got NOAA 15, 18, and 19, and you hear there's the frequencies. They're at 137.620 megahertz and 137.9125, and then 137.100. So what I was thinking about doing was taking this police scanner, or just general purpose scanner, and attempting to see if I could kind of stumble upon this. I'll have to go out in the backyard and freeze my keister off. It's a pretty chilly day today. It's below zero, but it might be fun to do. The other thing I'll need to do is see what kind of software is available to show me the track of the satellites. It might be something that might be web-based, or it might be something that's computer-based itself. I don't know. Looks like there's probably a little of both. But those are the basic chunks: the antenna, the receiver, and the decoder. I guess technically some kind of subsets of that are, the antenna tracking and some software that may run a receiver if I get a software-defined receiver. I don't know. It might be interesting to play with. So if you want to follow along, we'll kind of make a little series out of this and let you know what happens. One of the first things I'm going to do is tune up the scanner. And, well, it's not the first thing, but one of the first things I did was I did a little research on the internet. The second thing I'm going to do, to be correct here, is I'm going to tune up the scanner and find some satellite tracking data and see when these fly by, see if I can see anything, or hear anything more likely, and find out what's going on. So, if you want to follow along, that'd be great. If you have any questions or comments, feel free to leave them, especially if there's something I haven't thought of or I might find useful. I'd be more than happy to incorporate it into my little mad mini-series here. Anyway, take her easy. Have a groovy day.